Now let's discuss question number 49. It states to you that a solid metallic cylinder of height 10 centimeter and diameter 14 centimeter is melted to make two cones in the proportion of their volumes as 3:4. Keeping the height 10 centimeter, what would be the percentage increase in flat surface area? Out of these four options, you have to obtain the percentage increase in the flat surface area when a right circular cylinder is being melted into two cones. By this term flat surface area, we mean the plane surface area. So, when this cylinder is melted and molded into two cones, here the flat surfaces for this was top and base, and when it is obtained as two cones, here we are getting two bases as the flat surfaces. So, in this case, here it has the diameter 14 centimeter, so radius will be 7 centimeter and its height is 10 centimeter. This is melted into two cones of the height equal to 10 centimeter. Here it has the height equal to 10 centimeter. It is same as this one. Both have the height 10 centimeter. We are not aware about the radius. So, let's consider here it has the radius R1 and here it has the radius R2. So, now taking this into consideration, you know that when the solid is melted and molded into another solid, still the volume remains the same. So, we can definitely consider here that volume of this metallic cylinder is equal to volume of these two cones. So, I could next write here that for the solution of this, we can take up sum of volumes of two cones is definitely equal to volume of cylinder, is equal to volume of cylinder. So, here let us equate these two. So, volume of the cone is 1 upon 3 pi r square h. So, it will be 1 upon 3 pi r1 square h plus 1 upon 3 pi r2 square h. This is equal to further pi 7 square h, where I have h equal to 10 centimeter for these both. So, h will get cancelled up, moreover pi will be taken as common, that will also get cancelled up. So, in this case further you will obtain through this that r1 square plus r2 square is equal to, in this case we have r1 square plus r2 square because pi and h both get cancelled, 3 gets transposed to this side resulting here 7 square 49 into 3. Let us take it to be equation number 1. So, we have obtained this relationship between R1 and R2. Next, in this question you are being asked to obtain the percentage increase in the flat surface area. That clearly means the flat surface area of these two cones will be definitely greater than that of the cylinder. That is why we have percentage increase. Here in this case the flat surface area of these two cones will be given by sum total of area of their circular bases, that is pi r1 square plus pi r2 square. Talking about flat surface area of this metallic cylinder, here also we have the circular upper and lower end. So, area of that will be given by twice into pi 7 square, taking radius equal to 7. So, let us obtain here the percentage increased. So, I could write here percentage increase in flat surface area is very first total surface area, that is total flat surface area of two cones given by pi r1 square plus pi r2 square minus the flat surface area of cylinder, that is pi 7 square whole upon flat surface area of cylinder, that is twice into pi 7 square whole into 100. Now, let us simplify this one. You can easily take pi common from the numerator and denominator and cancel it out. Next, you can substitute here the value of r1 square plus r2 square from equation number 1. It will give you here 49 into 3, while here we will be left with 49 into 2. In the denominator, I have 49 into 2 whole into 100. We have obtained this with the help of equation number 1. That resulted that R1 square plus R2 square is 49 into 3. Next, you can easily simplify this. This simplifies to the value 49 whole by 49 into 2, where 49 gets cancelled. You have 1 upon 2 into 100. That gives me the required percentage increase equal to 50%. So here this is the required percentage increase according to this question. So out of the 4 options provided here, we can clearly mark the answer to be option number 3. Here this is the required answer for this question. Mark your answer as option 3. I hope it is clear to you. Now let's discuss our next question. Now let's discuss question number 50. It states that each vertical face of square-based vertical pillar of height 3 meter has 7 equal semi-cylindrical surfaces in such a way that its horizontal cross section is shown as in this figure. Next, this question states that if the radius of each semicircle is 10 centimeter, then the volume of the pillar so designed will be. So out of these 4 options, you have to obtain the correct answer. So coming back to this pillar, here we can see that in this case, height of the pillar is given to be equal to 3 meters. So that is in terms of meter. You can write it as 300 centimeter. Now, as we know, the height of this pillar is equal to 300 centimeter. Now, when you visualize this figure, it consists of 2 parts. In the interior, we have got a cuboidal block where it has the height of 300 centimeter. What will be here the other 2 sides of this cuboid? As here it has the semi-cylindrical surfaces which are 7 on each side, and each semi-cylindrical surface has the radius equal to 10 centimeter. So this h will be equal to twice into 10, that is diameter, 20 into 7, that is 140 centimeter. So if I just want to obtain the volume of the cuboidal block which lies in the interior, here that will be equal to 140 into 300 centimeter. Now coming to the outer semi-cylindrical surfaces, we have got 7 into 4, 28 such semi-cylindrical surfaces. And you know that volume of any object or any 3D shape is area of the base into height. If I obtain just the area of the base and take its product with the height, I'll clearly get the volume of this pillar. So let's firstly obtain area of the base, where this base will be equal to square of 140 because here it is a clear square. Each side is equal to 140, and coming to this semicircular part, here this will be equal to half pi r square, where radius is equal to 10 centimeter. So I could write next, in this case, volume of the pillar will be given by area of base into height, where this base consists of square and 28 semicircles. So it will be equal to area of square plus 28 into area of semicircles whole into height of pillar. Let's firstly write here area of the square base, as the side is of 140. So this will be equal to square of 140 plus I have here 28 into half pi r square. This will be equal to half into pi, where pi is taken to be 22 upon 7 and radius is given to be 10. Moreover, here when we talk about the height, that is 300 centimeter. I am taking all these values in terms of centimeter. So we will be getting here volume in terms of centimeter cube. Let's simplify this one. Here you will clearly observe that 7 into 14 simplifies 28 2 times, and it results here the value equal to square of 140, that is 19,600 twice of 22 into 100. This result 4400 into I have here 300. Let's simplify this one. When you add it up, on adding this, you clearly get the value equal to 24,000 into 300, which ultimately simplifies to the value that is this centimeter cube. Let's convert it in terms of meter cube. When you convert it in terms of meter cube, you get here 7.2 meter cube. I am getting your answer in terms of meter cube because options are provided also in terms of meter cube. So, the volume of each pillar is 7.2 meter cube. So, out of the 4 options given to you, now you can clearly state here in this question, the answer is clearly given by option number 4, that is 7.2 meter cube. You can definitely mark here the answer to be option 4. I hope it is clear to you. Now, let's take up our next question.